Okay, in this video, we're going to be talking about section 2-2, which deals with histograms. In the last video that I did, we talked about frequency distributions and how data can be represented using a frequency distribution. This video takes that frequency distribution and we can create what they call a histogram for representing or displaying data. Okay. Okay. So here we're going to talk about histograms. What we'll do here is develop the ability to picture the distribution in the format of a histogram or relative frequency histogram, and then examine a histogram and identify common distributions, including a uniform distribution and a normal distribution. Okay. So here, a histogram is an even better tool than a frequency distribution, as it consists of a graph that is easier to interpret than a table of numbers. Okay, so a definition of a histogram is going to be is a graph. It consists of bars of equal width drawn adjacent to each other, unless there are gaps in the data. The horizontal scale will represent classes of quantitative data values, and the vertical scale represents frequencies. Now, I do need to explain what quantitative data is. That's just simply numerical data. So here we're just going to be dealing with numbers in our data set. The heights of the bars correspond to the frequency values. Okay. Now, there are some important uses of a histogram. And that's this. A histogram virtually displays the shape of the distribution of the data. It also shows the location of the center of the data. It also shows the spread of the data, and it identifies something called outliers. And those outliers are considered to be data values that are far away from the other values in that data set. Okay. So here's an example of what a histogram looks like. Let's take the IQ scores from children with low levels of lead. So here's our frequency distribution right here. It's in the form of a table, as you recall in the last section or in the last video that I did. And from that, we can create what we call a histogram. So this is what that histogram looks like. And of course, the heights represent the frequencies here. Okay. So now let's go ahead and jump into an example that deals with the histogram. And before we do that, let me mention that a histogram is just basically a graph of a frequency distribution. Class frequencies should be used for the vertical scale, and that scale should be labeled. The bar locations on the horizontal scale are usually labeled with one of the following, either with class boundaries or class midpoints or lower class limits. The first and second options are technically correct, while the third option introduces a small error. Now, personally, I like to use option number 2, and that's the class midpoints. Okay, because the class midpoints usually, that's at the center of that entire class, and usually when you do the histogram, you can place those marks at the center of the vertical bars. Okay. Histograms can also be generated by using technology. Okay. So in example 1, here we have a histogram to the right that represents the weights in pounds of members of a certain high school debate team. And we want to know how many team members are included in the histogram. So we need to look at where the height of each individual bar is at. So like for this first one, the height of that is at 3. So that means that there are 3 here. And then plus the height of this bar is at 5. The height of the next bar is also at 5. The height of this bar is at 3. And then the height of this next bar right here is also 3. The height of the next to the last bar is at 1. And that last bar has a height of 1. So we're just going to take the sum of those numbers. Add 3 plus 5 plus 5 plus 3 plus 3 plus 1 plus 1. You'll end up with 21. So the number of team members that are included in this histogram is 21. Okay. All right, here's example 2. The table below shows the frequency distribution of the rainfall on 52 consecutive Thursdays in a certain city. Use the frequency distribution to construct a histogram. Do the data appear to have a distribution that is approximately normal? Okay, so here are classes. There are, in this case, 7, and each class that you see does have its corresponding frequency. So here's how I'm going to create the histogram. So here I'm going to draw a vertical axis. And a horizontal axis. Now I'm going to look at my frequencies here for this vertical axis here. I'm going from 4 to 20. Let's do our tick marks in increments of 2. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 20. So 20 is up here. So this would be 2, 4, 6, 8, 10, 12, 14, 16, and then 18, and then that's 20. So these are the frequencies. Now in this case, for my classes here, I'm going to use class midpoints. It's much easier to do a histogram when you're using class midpoints here, in my opinion. And here I got 7 classes here, so I'm going to do 1, 2, 3, 4, 5, 6, and 7. Okay, so let's find the class midpoint for 0 to 0.19. Okay. So what we do here is, if you recall in the last video, to find the class midpoints, you have to take the lower class limit and the upper class limit and add them together and divide by 2. So 0 plus 0.19 would be 0.19, and then 0.19 divided by 2 would be 0.095. So for this would be 0.095. And I'm also going to do this. I'm going to find the class width. If you recall, the class width is going to be the difference between any 2 consecutive lower class limits. So 0 from 0.20 is, of course, 0.20. That class width of 0.20 will help me come up with the other class midpoints here. So 0.095 plus 0.2 will be 0.295. And I might as well write this out. Class width is going to be 0.20 minus 0, which is 0.20. And I'm adding 0.20 each time to come up with the class midpoints here. Okay. All right, now 0.20 plus 0.295 will be 0.495. And then add another 0.2 will be 0.695. Add another 0.2 will be 0.895. And then add another 0.2 to the 0.895 will be 1.095. And finally, add another 0.2 to that will be 1.295. These are going to be the class midpoints for each of these corresponding classes that we see in this table. Okay, now we're going to do our bars here for this histogram. That 0.095 represents the class midpoint for from 0 to 0.19. The frequency there is a 20. So the height of that bar is going to be at 20. So here's how I'm going to draw the bar. And it is at 20, so I can draw the bar here. And I want that bar to be at the center of this mark right here. I want to draw the bar in the way so that this tick mark is at the center of it, because class midpoint is in the center or close to it. And then the next class midpoint was 0.295. That's going to be for 0.20 to 0.39. And it has a frequency of 12. So here's 12 here. So the height of that bar will be at 12. And that bar will be drawn in a way so that the mark for 0.295 is at the center, as you can see. And then 0.495 represents the class midpoint for 0.40 to 0.59. The frequency there is 5. Well, 5 is halfway between 4 and 6. So I'm going to put it halfway between 4 and 6. Draw the line this way. And I'm going to come down so that the mark is in the center, like this. And then 0.695 is the class midpoint for 0.60 to 0.79. The frequency there is 2. So at 2, I'm going to draw a horizontal line going here, and it's going to come down this way. And then 0.895, 0.895 is the class midpoint for 0.80 to 0.99. The frequency there is 5, which is halfway between 4 and 6. And it's the same height as the one for the class midpoint of 0.495. So I'm going to draw a line coming this way. This line meet up with this box. And that's how I draw that height of that box. And then 1.095 represents the class midpoint for 1 to 1.19. The frequency there is 4. So I got 4, so I'm going to put the line at 4. Come down like that. And then finally 1.295 is the class midpoint for 1.20 to 1.39. That frequency is also 4. So that height for that box will be the same as the one for the previous class. Okay. All right, so that's how I construct a histogram for this frequency distribution. Now, the other part of the question is, do the data appear to have a distribution that is approximately normal? Well, by looking at this graph, it's not going to be a normal distribution. If you recall in the last video, a normal distribution is going to have data values that start small and then increase to a maximum amount, and then starts decreasing. This is not the case. So here, we have to say no. Now we can also say this, that it is not symmetric. And the reason for that is this. When we say symmetric, that means the left side has the mirror image of the right side. And I'm not seeing that here in this graph of this histogram. Okay. All right, here's another example of a histogram that we're going to draw. The frequency distribution below represents the frequencies of actual temperatures recorded during the course of a 31-day month. Use the frequency distribution to construct a histogram. Do the data appear to have a distribution that is approximately normal? Okay. Now, this is what our frequency distribution looks like. Now, instead of coming up with the class midpoints for each one of these, like we did in that last example, here we got classes listed as A, B, C, A through G. So let's use those. Okay, so let me go ahead and draw the vertical and horizontal axis. Let's see. There's 7 classes here. So here, I'm going to do 7 marks here. I'm going to label these as A, B, C, D, E, F, and G. Let's see, my frequencies are from 1 through 8. So I'll just do this on the vertical axis: 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this is the frequency. And I should go ahead and label this as class as well. Okay, so for class A, the frequency is only 1. The frequency is only 1. Okay, so let's do this. The height will be at 1. And I'm going to try to draw the vertical bar, the bar of the histogram in a way so that the mark is at the center of that bar. And then for B, there's also 1 as well. So it's going to have the same height as class A. And then for class C, the frequency is at 8. So that's going to be the tallest bar right there. Okay, so what I'm going to do here is just draw this bar upward to where 8 is. And we're going to come down here. Okay. And now for D, that frequency is 7. Okay. So at 7, that's where the height of this bar for D will be at 7. And then for E, class E is also 8, which will have the same height as C. Okay. And then for F, that height is 3. Well, the frequency is 3, but the height of the bar is going to be at 3. And then G also has a frequency of 3, so the height of that bar is going to be the same as the height for class F. Okay. So that's what the histogram looks like. Then the question is, do the data appear to have a distribution that's approximately normal? Starts off low and then goes up to a few high numbers. The height gets taller and then starts to get smaller, with smaller numbers here. So this would be approximately a distribution that is normal. So yes, it is approximately normal. It is approximately normal. Okay. Okay, here's another example of a histogram. And that's this one. The last digit of the heights of 39 statistics students were obtained as part of an experiment conducted for a class. Use the following frequency distribution to construct a histogram. What can be concluded from the distribution of the digits? Specifically, do the heights appear to be reported or actually measured? So here, the digit from 0 to 9 and their corresponding frequencies. Okay. So I'm going to draw a vertical and a horizontal axis. There are 9 digits from 0 through 9. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And the frequencies, the lowest is 3 and the highest is 5. I can just do this as 1, 2, 3, 4, and 5. Okay, and then we're going to draw those bars. All right, in this case here, for the digit of 0, the frequency there is 3. So the height of that bar will be at 3. Okay. And at 1, its frequency is also 3. And also at 2, that frequency is 3. So at 0, 1, and 2, those heights are going to be at 3. And those bars are being drawn in a way so that those marks on the horizontal axis are at the center. And then for 3, that frequency is 5. So the height of that bar would be at 5. Okay. Let me find out that. All right, now for 4, the frequency there for that number is 4. So the height of that bar would be at 4. And for 5, it's also has a frequency of 4, has the same height. And then for 6, the frequency there is 3, which has the same height as 0, 1, and 2. And then for 7, the frequency there is 5. That's going to have the same height as the one for 3. And then for 8, the frequency there is 4, having the same height as 4 and 5. And finally, for the 9, the frequency there is 5, has the same height as 7. All right. So there's your your histogram for that frequency distribution. Okay. Now, in this case here, they do ask the question specifically, well, what can be concluded from the distribution of the digits? And specifically, do the heights appear to be reported or actually measured? All right, so let's kind of think about this one for a moment. Okay. In this case here, the data appears to be measured. Okay. So by looking at this, the data does appear to be measured. And do the heights appear to be reported or actually measured? Okay. And in this case here, as we say, the data does appear to be measured and the heights occur with roughly the same frequency, as you can see with most of these. Okay, so here we can say the heights occur with roughly the same frequency. Okay. Okay. And by the way, in the homework, you'll be given a choice of answers to help you answer some of the questions that might want you to kind of think about what that that histogram looks like. Okay. Okay, next we'll look at a relative frequency histogram. Now, relative frequency histogram, if you would call a relative frequency distribution, instead of the frequencies, you have the percents as their relative frequency. The same thing is true with a relative frequency histogram. It has the same shape and horizontal scale as a histogram, but the vertical scale uses relative frequencies as percentages or proportions instead of the actual frequency. So here with the IQ score for children with low levels of lead, those were the percentages here. And instead of the vertical axis being the frequencies, the vertical axis is now the percent. Okay. Now here they're using class boundaries here, but you can use the class midpoints like I did in the previous example. In one of the examples that I did, you can still use those class midpoints. Okay. Here's some critical thinking when we're interpreting histograms. The ultimate objective is not creating a histogram, but rather understanding something about the data, okay? Like the normal distribution. When graphed as a histogram, a normal distribution has a bell shape. In a normal distribution, the frequencies increase to a maximum and then decrease. And number two, the graph has symmetry with the left half of the histogram being roughly the mirror image of the right half. So that's pretty much what we was trying to answer in one of those examples that I just did that talks about whether or not the histogram appears to have a normal distribution. Okay, and here's some common distribution shapes. One of them is a uniform distribution. That is with a uniform distribution, the different possible values occur with approximately the same frequency. So the heights of the bars in the histogram are approximately uniform. And on the next page, you'll see a graph that looks like a uniform distribution. Okay. All right, next we'll talk about skewness. Sometimes graphs are not always normal. They could have skewness in it. Okay, a distribution of data is skewed if it is not symmetric and extends more to one side than to the other. And we got a few graphs that are like that. Like this one right here. Data is skewed to the right, or as some textbooks call it, positively skewed. And usually they will have a longer tail. Okay, so this is a graph of a histogram that looks positively skewed. Here has a right longer tail on the end. So that's skewed to the right or positively skewed. Now for something that's negatively skewed, that data will be skewed to the left and has a longer left tail. So here's the left tail right here. That tail is longer there. So it's skewed to the left or negatively skewed. Okay. All right. The last thing I'm just going to talk about in this video would be assessing normality. And that's going to be the use of a normal quantile plot. And with that, you're probably going to need to use technology in order to assess normality. Histograms are often helpful in determining where the normality requirement is satisfied. However, they're not helpful with small data sets. Assessing normality is where we determine whether the sample data are from a normally distributed population. To assess normality, we construct normal quantile plots, which involve plotting transformed sample values. Normal quantile plots are easy to generate using technology. And we'll be using StatDis in our StatDis assignments. So pretty much make sure you downloaded StatDis if you're in my class. An interpretation of the normal quantile plot is based on the following criteria: whether it's a normal distribution or not a normal distribution. If it's a normal distribution, that means the population distribution is normal if the pattern of the points in the normal quantile plot is reasonably close to the straight line, and the points do not show some symmetric pattern that is not a straight line pattern. Now, if it's not a normal distribution, that means the normal quantile plot has either or both of these two conditions. The points do not lie reasonably close to a straight line, or the points show some symmetric pattern that is not a straight line pattern. So here's some examples of normal quantile plots. This one has a normal distribution because, as you can see here, the points are reasonably close to a straight line pattern. And there is no other systematic pattern that is not a straight line pattern. So this is close to a straight line. So we can consider that having a normal distribution. This one does not have a normal distribution. And that's where the points do not lie reasonably close to a straight line. Here's where the points are right here. And finally, this one that you're about to see does not have a normal distribution. It shows a systematic pattern, but it's not a straight line pattern, okay? Because in this case, it looks like it has a curve in it. Looks like it's going to be in the form of a curve, but not a straight line, okay? All right, so that's all I need to discuss in this video, and that will complete this video on section 2-2, dealing with histograms. And if you have any questions, please feel free to email me if you're in my class. And I wish you the very best in your in completing this homework assignment for that section.